Hello guys, welcome back to Backend Horizon, and today we're gonna talk about AWS Step Functions. Let's talk about one of my favorite services, to be honest. I really like to use AWS Step Functions to organize or, like they said, orchestrate my services, so I can connect a bunch of different services and split my flows. So we can have smaller units instead of these very big and fat lambdas. So let's talk about it. Okay, let's take a quick look in watch the example that we're gonna check together. Step functions, it's basically a way for you to create some flow, some application, kind of in the format of a diagram and a state machine. So you can see here the example that I'm gonna show you guys. It's a CCM application, simulating a CCM application, of course. And CCM means Communication Customer Management. So it's a type of software that helps you to communicate with your customers. And so this kind of applications usually help you communicate via SMS, email, or even it serves as a template for letters. So yeah, there are a bunch of these applications in the market, and we kinda gonna do this example that simulates one. It's a very simple example, and you can see here on the right that we have a diagram for that, where the first step is to read some file from S3, and we do some checking. We're gonna look for the communication keys in our payload, and if that is totally correct, we're gonna process these communications. If it's not, the application is ended basically. In the case where we have payloads, our fake application gonna check for SMS or email, and if it doesn't find any of this type of communication, it ends up in type not found or not supported. This step is kind of a failure for us. We're gonna see in a few minutes. And after all this process is done, we collect some analytics, and we could, for example, think that we could have some steps here checking if all the communications were sent or the amount of communications, and etc. etc. It's just a fake example, and I'm gonna show you also the code later. But that's kind of the purpose of the step functions. Is all this we could have in one big lambda that would do all these steps, or we could even split this into different lambdas. That is our case here actually, where each unit of work that is called steps in step functions, it's a different lambda. And since each step is a different lambda for us, what step functions gonna help us? It's basically to glue all these different steps together and construct basically this flow that you're seeing. Something that I love about step functions, and it's not even a technical thing, it's the fact that when we have our flows constructed with step functions and we have this diagram that you are seeing, it's super useful to just remember what the flow does. It already happened a bunch of times with me that sometimes I need to return to some flow, do some change, check up some error months later, and sometimes it's you don't even remember what that flow does. And if you have your flow done with step functions, at least you have this diagram, and it really helps you to remember, at least at high level, which steps are done in your flow. So super useful. And this is our example. And if you wanna know a little bit more about step functions, of course there is the documentation that you can give some reading here. They are basically saying this, that Step Functions is our orchestration service. It's a serverless service from AWS. And yeah, you can do some reading here. You're gonna see that they also mention about standard and express workflows. And Step Functions, they have these two types. Yeah, you can give some reading here, but I will not touch this topic for today. The most important thing that we're gonna cover today, I wanna create this example with you, and we're gonna do this also using CDK. And if you never used CDK, I already have a video at my channel. Check that first, so it's more clear for you what we're gonna do today. Here we have the state machine that we're gonna build. That's the first example that I did to show you guys. And yeah, when you have a state machine and already deployed, of course, you can come here in the definition and we can see a very nice looking picture of how our state machine gonna be in the end. And at the left, you can see this JSON, kind of JSON language. That is what AWS call ASL. And in theory, you can build your state machine using this JSON, but as you can see, it's not the easiest thing to understand. It's a little bit verbose, and yeah, it's a lot of configurations, and yeah, not very easy to spot what each step is doing. Okay. Personally, I never built step machines like this. I always use CDK for that. And at least my opinion with CDK, it's way more clean the code and way more easy also to understand. Okay. But yeah, it's good to know that in the end, when CDK builds our code, what gonna happens is that it's gonna generate all the CloudFormation template and also this definition of your state machine. So in the end, the code gonna be this one. Okay. And I also wanna show you that there is a very nice tool from AWS that you can play a little bit, and yeah, you can see how you can build this also not just use CDK but also via user interface. So yeah, as I showed, you can come here in the step functions, and if you create a new step function, AWS also provides a few examples that you can use. You can start with one of these examples, build on top of that, or start from scratch, of course, anything that you want. I'm gonna just get a random one here to show you what I mean. Yeah, you can choose some template. I will choose to build on top of it because I don't want to deploy this example in my account. And yeah, let me see if I can zoom a little bit more. Yeah, you can see that there is a lot of possibilities. And also it's good to mention that in our example, our state machine, it will be mostly running some lambdas, but you can do a lot of different things and with step functions. You can read files from S3, you can read data from a DynamoDB database without the need of any lambda. And yeah, in this UI, you have a lot of different components here, and you can basically assemble your state machine. You can just, choose some service and some action, some one of these all different components, and you can just drag and drop. And this will basically construct your state machine and generate that ASL language that we saw. Yeah, I think if you change here, you can see that when you drag a new component, it what basically does is start to edit that ASL script that we saw. And yeah, you can build your state machines like this also if you prefer. And if I'm not wrong, you can copy and paste this ASL script and also load in your code. I think that's also fine. Let's take a look in our example then. I already created a few things, so we're gonna not go into the entire example. Let me quickly show you what I have for now. If you remember from our diagram, we have a few lambdas that we need to do our CCM example, right? So we need the email, SMS, another one to read the S3 content, and the analytics lambdas. So all these 4 examples, they are here, application source, and you can see the lambdas itself. Most of them they don't do anything special. It's mostly logging the event that they receive in the lambda. Same for email and analytics. The S3 lambda, it does a little bit more. So what this lambda does, it's basically based on a source event received in the bucket. It reads the content and it will return the content of the file for us in our state machine. Okay, so very simple, just reads the file content and return to us as a string in the state machine. Also, let me quickly show you some example of our payload. So this is the payload that we're gonna put inside a S3 bucket, and our lambda gonna read this data and put in the state machine for us. You can see that it's a JSON that has a communications keys, and if you remember, there is one step here that we validate if we have this communications key present. So that is the key that I mean. And for each type of communication, we have the type key, that is, we just have SMS and email. That is basically the validation that we are doing here. And if we send something else, we're gonna fall for this failure step here, that is the type not found or supported. And we have another example here. It's just a little bit more data, exactly the same. Okay. Also in our npm, package JSON actually, I just put some other scripts here to do the deployment and also to easily destroy your stacks after you're done with the testing. And there is also some dependencies here to help us with our example. Following up, if you saw my SDK video, you know that our infrastructure starts in the bin folder. So here we have a stack, and inside this stack we have our class stack that we're gonna define a few things here later. But for now, let's start to create our state machine itself. So I will create another folder called state machine, and we will create a file called communication step machine. And let's create a class for that. State machine, and this needs to extend state machine. I also already gonna create some interface, that is the props that we need to receive. So I will get an email lambda. That is our not lambda function, but Node.js function. SMS lambda, analytics lambda, and the read content lambda. Also Node.js function. Okay, so in our class we need to create a constructor. Let's already set the autocomplete. So we need a scope, yes, ID props of type the interface props that we just created. Okay. And yeah, that's not really necessary for now. Let's just leave a definition here. Okay, so definition, it's where our step machine starts. So just to start, I will create an empty step. Let's call it pass, and it is scope, and it's empty. And you see that if I use my empty step as my definition, we already have my state machine. So of course this state machine doesn't do much, would be just start and have an empty step that executes, and that's it. So let's look our diagram. The first step is the read S3 content lambda. What I'm gonna do, just to speed up things a little bit, I will create a function and call it create lambda invokes, and in this lambda I need my scope and also my props. Yeah. So what this let me see. Oh yeah, I think I need this inside the constructor. Yes. So let me create one example first. Let's create our email lambda for now. New lambda invoke. Yeah, scope email lambda function, and output just okay. So even though we are getting a Node.js function here, we can just put this Node.js type inside our state machine. So we need to encapsulate the lambdas with a lambda invoke, and you're gonna have a few parameters here, and basically what this is doing, it's saying, okay, create a lambda invoke, and let's put a better ID here. So email lambda, yes. And for now, the only thing that we're gonna see for this lambda is that whatever it executes, the output path, it's this one. The $sign basically means the root. So you need to understand that when the data flows between all these different lambdas in the state machine, it's serialized. So it's basically a lambda that we propagate between steps. And when we say $sign, it means that is the root. Okay, so whatever data we would include, propagate to the next step, it would be part of the root of the data. Okay, so we also gonna create another thing first. In step functions, it's also possible, if you have a lambda, for example our email lambda, let's imagine that you had some problem when you're trying to execute the lambda and it fails for some connection problem, let's say. In step functions, it's possible that you can retry each step of the state machine. So back to our diagram, let's imagine that you put a batch file in S3, the state machine and the lambda read the content, it validated that you have the communications key in the payload. We're gonna do this step just in a minute, and when it comes here, we also validate that it was a SMS or email type. And right here in this step, when you try to send the email, the step failed. So would be a bit of a struggle for you to implement all this again, right? You would need to filter just this data, this step for one specific email, for example, that failed, and you will need to execute that again. That's not really necessary. So step functions, they have this retry implementation natively. So what we're gonna do is we're gonna implement a retry. So retry on failure, that is retry props, yes, and we're gonna specify which errors that we want. There are different errors that step functions support. For now, we're gonna use basically all states, all. Of course, you can find all these different errors in the documentation. For now, I would say that any failure that happens in this lambda, it would retry. We have max attempts that we want to retry, so I will put 2. So if the lambda executes once, it would retry again 2 times. Back off rate, yeah, I will put also 2, and interval duration, yeah, 10 seconds. So the back off rate means that since it's 2, it's gonna double the interval each time that it retries. So the first time we would retry 10 seconds later, and in the second retry 20 seconds later. And in our lambda, we're gonna add this retry failure. Okay, so this is already sufficient for our email lambda to basically retry when it fails. Also, let's also implement the other lambdas. It's basically a copy and paste, and we have the SMS lambda and SMS lambda. Yes, the same. And the analytics lambda, yes, analytics. Oh, I forgot to change this. So SMS analytics. And I will have the read content lambda, and yeah, I don't want to retry this one. Read history content. Okay, so we created our lambdas, and what I'm gonna do is return all of them. So email lambda, SMS, and analytics, and the read content lambda. Okay, so here in the beginning of our state machine, I will just call this function email, SMS, analytics, and read content lambda equal create lambda invokes. Yeah, scope and props. Okay, so we got our props from our interface here, so the reference for the lambdas, and for each of them we create one lambda invoke. So now let's create the first step. Remember that I told you that the first step is to read the content lambda, right? So if we get this lambda and say that the definition it's this lambda, we already have one step machine that works. So that would just read the content and that's it. But yeah, of course we don't want just that. Let's put like this. Okay. So this first step is reading file content. Okay. Since we are doing this by code, and the second step kind of depends on the first step. For the step functions, we kind of need to code the steps in reverse order, right? So we have the content lambda here, and the second step is to validate if the content that came has the communications key. So what we're gonna do is okay, so second step, validate if communications key is present. For that we need to create, first let's create a condition, is communication key present, and for that we need a condition is present. Yeah. And how we check that? So it's present in the data that we are passing between the steps, payload dot communications. So payload is basically it's a key that comes when we read the file from the S3. So if you get the logs in the lambda right after we read the content, so basically the data that we are propagating that lambda, it comes inside this payload, and communication, it's already the key that we have in our example. So for that, now we need to create something called a choice. A choice, it's basically an if else. It's all the different choices that we have here. And the condition, it's how we validate the condition for that choice. So we need let me see, communication validation, communication key validation, new choice, our scope, and let's put this communication key present. You see that the IDs that I'm putting here, it's the IDs that we see here in the diagram. Just pay attention that if you can of course choose this very easy to understand message to see in your diagram, but be careful if you choose the same string, the same text for multiple different steps. Probably you're gonna have a failure when you compile your code, because they need to be unique. Okay, so just pay attention to this. Okay, so we create a choice, that is the how we're gonna deviate, and we can say communication validation when, and our end we say what is the condition, is communication present, what we do, right? So if you look in the diagram again, when the communication key is present, what we're gonna do is we're gonna iterate through the list to send the communications. So for now, let me just process batch map. This doesn't exist, but it's gonna be in a second. So when communications key is present, we're gonna run our map through the list. But if it's not, so otherwise, we gonna fail this step. So new fail, again scope, and communications key not found. That is this flow, you see? So if the keys are not present, we failure basically the entire flow. And we need to say that we need to connect the flows, right? So after the invoke of the read content lambda, we need to say that the next step is our communication key validation. So this will connect this lambda to this choice. Okay, pretty straightforward, right? So now the next step is to iterate through our list. So we're gonna process our batch. So let's create a process batch map. That is a map. Yeah, there's map scope, and we're gonna call process batch. Let me just ignore the suggestion. Process batch, and we need to give some arguments. The first argument is where the items are. So in items path, we say the JSON path string at payload communications. And we can also say where the results of this map will be, and we can say that is, for example, in the routing process. So this is the entry for the state machine and the results. If I'm not wrong, I think I don't even need to put this JSON path here, but yeah, let's leave like this. And if you also want, you can also put some concurrency in this map. Let's put like 2. So this means that when this map is running, more than one item in concurrence. Okay, so this can really speed up your state machine. Okay, so the state machine is already linked to the choice condition, and now what we need to do is say what we're gonna have inside our map. So again, the fourth step now is to trigger the right lambda based on the communication type. So again, we're gonna have another choice. Let's call it type choice. Yeah, let's put like in the diagram, that is SMS or email. And our type choice will say when condition on the type is email, we need to trigger the email lambda. So we say email lambda. So we already have the lambdas here, right? split like this, or when condition is type SMS, we call SMS lambda. We just have these two types, so otherwise new failure, and we say invalid communication type. Or let's put a better message here, like in the diagram, type not found or supported. Okay, so now we need to tell to the map, our process batch map, that item processor type choice. So we are saying that inside our map, this choice is where it starts, right? So the first step inside the map, SMS or lambda, that is our choice. And depending on what we receive on the type, we're gonna call one lambda or another. Okay? And after the map is done, we will say process batch map. The next step is the the analytics lambda. And I think this concludes our state machine. So let's do a quick review. So we need to, of course, leave the constructor on the end, and the constructor expects a definition, and the definition is the first step in our state machine. So the first step is to read the content of the S3 file. After we read, we need to validate if the content has communications key. For that, we create a choice that will use a condition to validate if in the payload that we are transitioning in our state machine, if this payload has a communication key. If it has, it will move to the map where we'll process the lambdas, but if it doesn't, it will fail the flow. In our map, we configured to be concurrent, so two items will be processed at the same time. And we expect that the entry point for our map is a payload that also has a communications key, so its path, it's the entry payload, the entry point, sorry, and the results will be published in the process node. We can see this all these keys later in the after we deploy the state machine. Okay, so inside the map, we need to say where our map starts, so what's going to be the processor in the map, and it starts doing another check that if our content is a SMS or email, and also you can notice that now that we are inside the map, we are talking about individual items. So you can see that we don't need to do the communications, we don't need to do $, payload, communications, and blah 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 and more. We already specify directly the item. So when we are inside the map, let me find here our example. Okay, so when we are inside the map, we move our context to each of these items. After the map runs, we move to the analytics. So yeah, imagine that we could collect some data to see what was processed or not, and so on, right? You understand. And I think this concludes our diagram for the state machine. So what we need to do now is to create the rest of the infrastructure that this state machine requires. So let's create the rest of the infrastructure. So now we already created the state machine, and now we need to create all the rest of the lambdas that this state machine received and so on. Just a reminder that what we created here, we didn't create the lambdas itself, but we just created a lambda invocation. So now we're gonna really create the lambdas. If this sounds a little bit confused, please check my other video about CDK, and I'm sure that it's gonna be way more clear for you. Okay, so let's create the rest of the infra. So now let's create the lambdas. Let's create the send email lambda, new Node.js function. This receive this. Yeah, let's use default. So send email lambda, the entry point, it's actually application source, and it doesn't have this. And let me just confirm it here. Send email lambda. So send email lambda. Send the email. Yes. And it pointing handler. So handler because this function here starts it's called handler. And we're gonna use runtime. I use Node.js 22. And again, let's do the same for the other lambdas. 4 lambdas created, and now we're gonna create a state machine. So communication state machine, new communication state machine. The scope is this. The scope needs to be the stack scope, so that's why we are passing this here. The ID, yes, it was uppercase here. Okay. Okay, so we create everything the state machine itself needs, but there is a few other things. Remember that I said that our flow starts with us dropping a file in a bucket. So the flow, our state machine is gonna be started when we put the file in a bucket. You can also test the state machine. If you come to your state machine and you want to start execution, you can also put the payload here. And the way that the payload is in the project, it's gonna not execute with success because our state machine is expecting to have dot payload and the communications key inside a payload. That's the way that we are reading from the S3 content lambda. But anything that you want to test, you can put it here and you see your state machine being executed. But for our example, what we need to do now is to create a bucket. So let's create the batch bucket. So new bucket. This, let's call batch bucket. And we also need, let's give some, it's already here. We need to grant some permission, but not to the bucket, but for the lambda, read S3 content lambda. So this is basically saying that this bucket gives permission to the read S3 content lambda to read the data inside the bucket. Okay, so right after giving the permission, what we need to do now is when we drop a file in S3, what happens is that S3 we'll put a message in a SQS queue. SQS queue, it's very good in cases that if something goes wrong, you can retry, right? So the message will not be removed from the queue if the entire state machine, for example, failed, and that message would keep there. So let's create a queue, batch queue, equal new queue. Yes, SQS queue, and yeah, let's batch queue. It's fine. And what we need to say is that my batch bucket, we need to add an event notification. So this means that when some event happens in the bucket, we're gonna do something. In our case, when we receive a object create event, we want a new message to be put in the queue. New SQS destination on for the batch queue. Yeah. I think the import's wrong. No, not this one. Has 3 notifications, yes. What is wrong here? Duplicate. Okay, so now when the file is dropped in S3, we are already gonna have a message in the queue. And the next step, it's basically to say, okay, when I receive a message in my queue, I want my state machine to be started based on this message. There is a few ways that you can do this. One way would be to have your queue starting a lambda, and the lambda would start the state machine using the SDK. There is another way that I like more, that it's a little bit more complicated, so I will not type the entire code. I will just paste it here and we go step by step. That is using something called pipes. So let's fix the imports first. So the way that the pipes works, it's basically pipes, event bridge pipes, is something that you can have a consumer and a producer. So basically when a producer, in other words, someone that produces some message, some event, it's sent for a consumer, so someone that they're gonna consume this event and do something. So the way that this works for us is when we receive a message in the queue will send this message to a state machine. So it's basically a easier way for us to connect two services. Okay, so you can see that we need to create some policies saying that we are able to receive message, delete message from the queue, get some attributes, and the target policy, our state machine, we need to start an execution of that state machine. And yeah, there is some roles that are necessary to create, some configurations here, and what it says is basically fire and forget. So this means that the queue gonna receive the message and gonna start the state machine and doesn't wait for the response. So in our case, the queue, it's not checking if the state machine it was succeeded or not. And yeah, later on you can do some reading with the documentation regarding the different types of state machines, the express and standard, and especially regarding the standard state machines, this one that we are using, there is one characteristic that is this kind of state machine can run up to 1 year. So in our case, I imagine that with this kind of integration with the SQS, you could not retry that in the queue, because messages in the queue cannot live for that long. Okay, so in our case, the only possible integration is basically fire and forget. So the queue will start the state machine and it will not wait for the response. Okay, so the only thing that is missing now, we need to say that we need to create a pipe between our queue and our communication state machine. Now let's deploy our application. Okay, so our application is deployed now. So let's go to AWS. And yeah, we can see our stack here. Let's go to resources. And we can see our lambdas, our bucket. So what is important for us now is our bucket and our state machine right here. Yeah, we can open, and you can see that the definition is what we created. And as I said, the CDK code, when it compiles, what does in the background, it creates the ASL code. So everything that we did here, it's basically the same what we did in CDK, but at least in my opinion, way more clear and easy to see what's going on. Okay, so let's test. Let's go to our bucket, and now I'm gonna drag one of the payloads that I show you. Upload. It's uploaded. So we should see, yes, we already can see that it was executed. And yeah, if you click in the steps, you can see some information of each step. Here it's basically the data that we receive from the event creation, and when we drop the file in the bucket, yeah, you can see all the data here, a lot of things. And we can see also the output, that is basically our payload. And as I mentioned, you see that there is the payload key here, that is the result of the reading. And what we basically do, we get this payload and we start to propagate that through the entirely state machine. When it comes here to the map, you can select the map, and it's also possible to see all the steps that it did. So it had 3 items there, right? So you can see that the first one, it was an email, the second SMS, and the third also SMS. Let's do another testing with the other payload. I'm gonna drag the second payload that has more data. And again, let's refresh. You see that it's still running. For long operations, you can even see, yeah, like this one, you see that it's happening right now. When it's blue, it's in progress. Let's wait to finish. And yeah, it's done. And if we go to the map, we can see that all the 25 were succeeded. Just as an example, what I'm gonna do is I will change this payload for an invalid type. Let's say a WhatsApp. Let's imagine we're trying to send a WhatsApp message, right? So back to the bucket. This will override the file that is there, and that will trigger again another state machine. Yeah, and you can see that this had a failure, because of course the type that we use it's not supported. But as you can see, we had 2 successes here, because not all 3 communications there were invalid, but just 1, and 1 failure. There are ways to handle this. You can failure the entire flow as it happened. You could have just this partial failures. There is a lot of different possibilities and with these state machines. Okay, I hope that it was a good introduction for you. If it's a bit confused, the coding part, again, I highly recommend for you to take a look in the CDK code that I did. The other CDK video that I did, and yeah, definitely it will help a lot to understand. Okay, have a nice day, guys, and see you in the next one. Bye bye.